The promise of smart homes, offices, classrooms, and indeed the entire Internet of Things relies on robust sensing of the environment. There are two ways to achieve this today. One option is to upgrade one's home with smart appliances. However, these are expensive and rarely talk to one another. A more flexible option is for owners to tag existing objects with aftermarket sensors. This adds some level of smartness, but requires many tags and can be socially and aesthetically obtrusive. We explored an alternate, general-purpose sensing approach, wherein a single highly capable sensor board can indirectly monitor an entire room. We started our research by building an inventory of sensors used in commercial and academic systems. We decided to include all of these sensor dimensions, but no camera, as this sensor is particularly sensitive to users. Our sensor board is plug-and-play, uses wall power, and connects to our cloud backend over Wi-Fi. A single sensor board in a room can capture a wide variety of events. On the right, you can see our board's raw sensor streams. This faucet running is easily seen in both the acoustic channel and by our high-speed accelerometers. Here we can see data from 3 different motor-powered appliances: a garbage disposal, a blender, and a coffee grinder. Note how each results in distinct sensor signals. Now the user turns on a stove burner. Note how the thermal image reveals not only that the burner is on, but what burner and how hot it is. Of course, this low-level sensor data is rarely of interest to users. Instead, we use machine learning to automatically recognize patterns of sensor activation and expose these high-level environmental events as synthetic sensors. Although virtual, they can be treated just like traditional physical sensor feeds, triggering user-defined functions or used by developers to build responsive applications. Importantly, raw sensor data is never sent to the cloud. Instead, it's featurized in our sensor board, which helps to anonymize signals before transmission. Our system works across many different settings. For example, the shower in this bathroom, the 2 vanity faucets, various bathroom accessories, the toilet flushing, and the state of lighting. We can also detect multiple events in the house, including when a fireplace is on, the water tank is heating, the dryer is running, and when the HVAC is on. In a workshop or industrial setting, we can detect multiple events such as when the dust filter is running or the exhaust fan is on. Different tools such as saws, a shop vac, a drill press, a grinder, and various handheld tools. In a workplace or an office, we can detect a suite of events, such as if a phone is ringing, we can detect writing on a whiteboard, and also erasing. A water fountain running, urinals flushing, and paper towels dispensing. The synthetic sensors seen thus far we call first-order synthetic sensors. However, these basic synthetic sensors can be fed into second-order synthetic sensors, able to capture higher-level semantics such as count, duration, and state. For example, a first-order towel dispense sensor can power a second-order sensor that tracks the number of towels used. With such a sensor, a facilities manager could automatically receive alerts or schedule restock requests. In this example, a first-order faucet running sensor is used to power a second-order water consumption sensor. Metrics like this can inform monitoring, behavior change, and other applications. Finally, more complex devices can have multiple states, beyond just on or off, like this microwave. Here you can see first-order synthetic sensors responsible for recognizing individual states. By building on top of these sensors, it is possible to create a second-order sensor that tracks the state of the device. Armed with this high-level understanding, richer assistive applications can be built. Finally, there's no reason to stop at second-order synthetic sensors. These can feed into higher-order sensors, able to capture more complex environmental facets, like human activity and the mechanical health of objects. Please see our paper for more details. Thanks for watching our video.